Yeah, it's your teacher that they cause. And this day we'll be talking about air and the composition of air. Air is a mixture of gases containing uh, about four or five gases in them. And nitrogen is a major component of air, as you can see from this chart, followed by oxygen, about 20.95%. Argon is about 1%, and in fact is the most abundant noble gas present in the air. Carbon dioxide makes up about 0.03% in air. Then impurities, that's water vapor, dust particles, and some other gases, makes up about 0.01%. So according to this chart, you will see the composition of air: nitrogen, oxygen, other gases, argon, carbon dioxide or carbon dioxide. All right. Why do we know that air is a mixture? Ordinarily, when you see air, it is very difficult to assume that air is a mixture. But there are some evidences that let us know that air is a mixture. For example, the constituent of air can be separated by physical method. That is, if air is a compound, you cannot separate air by physical method. But we know that we can separate air by liquefying it and performing a fractional distillation on it. So that shows us that air itself is a mixture. All right. Secondly, if you mix appropriate constituent of air together, there will be no evidence of chemical reaction. If you mix oxygen with nitrogen and you not raise their temperature, then there will not be evidence of any chemical reaction in them. So air itself is a mixture. Then the composition of air cannot be represented by a single chemical formula. If it's a compound, air should have a chemical formula. But because it's a mixture, air cannot be represented by a single chemical formula. Then number 4, the component of air still retain their individual properties, both chemical and physical. For example, you can selectively remove carbon dioxide from air by using soda lime or caustic soda. Alkali solutions will remove carbon dioxide from air. That means if carbon dioxide has reacted in air, then you cannot separately or selectively remove it. That means these gases present in air are actually present there as mixture. You can also selectively remove oxygen by passing it through an alkaline pyrogalose solution. Alkaline pyrogalose is benzene 1,2,3-triol. Or you can also remove oxygen by passing the air over heated copper. So heated copper will selectively absorb oxygen from air mixture. You can also remove water vapor from air by using a concentrated solution of H2SO4, fused calcium chloride, or even quicklime. All these three compounds are drying agents. They are drying agents, so they have ability of absorbing water vapor anywhere it is present. And because of that, if you can absorb water vapor selectively from air, you can absorb carbon dioxide from air, you can absorb oxygen from this same air. That means air is not a compound. Then surely it's a mixture. It's a mixture. Then nitrogen and air gases still remain unreactive even inside the air. You can see now, if you are given this, for example, if you are given this, we have air. This is air. You are using, this is water now. Water will push up the air inside the bottle and it pass through this place. As the air enters the sodium hydroxide, carbon dioxide will be removed from here. So this one remove carbon dioxide, as you can see. So the remaining component of air will enter this place and enter into the tube containing H2SO4, and that H2SO4 will remove water vapor present in the air. And if you now pass the remaining into a combustion tube, this is a combustion tube containing red hot copper. You can see this Bunsen burner heating that combustion tube. So any content of the combustion tube is going to be hot. So this is red hot copper. So as the air passes through this combustion tube, all the oxygen inside the air is going to be absorbed, and then you'll be left with nitrogen gas and argon, because those ones cannot be removed by chemicals. They are chemically unreactive. So this simple experiment tell you that air itself is a mixture, as you can remove the components by different chemicals that those components are reactive to. So you can try this exercise. It's a UTME question. A stream of air is passed successively through 3 tubes X, Y, and Z containing conc aqueous solution of KOH, red hot copper powder, fused calcium chloride respectively. What is the composition of the gas that is emanating from each tube? Now, what they're asking you to do here is this. It's similar to the previous slide. What will KOH remove? KOH will remove, because it's an alkaline solution, it removes carbon dioxide, right? So all other components will pass through this tube having KOH apart from carbon dioxide. All the CO2 in the component will be absorbed. Now, when you get to a tube containing red hot copper, now red hot copper will absorb the oxygen. That means here now we have lost CO2. Here we are going to lose oxygen from the red hot copper. Then the fused calcium chloride will absorb water vapor. So here now water will be removed out of the component of air. I like to call them NOAC. N for nitrogen, O for oxygen, A for argon, C for carbon dioxide. So we have removed oxygen, we have removed carbon dioxide. Then if there's water vapor, so it will be removed by calcium chloride. Now we are left with nitrogen and argon. So only nitrogen and argon will be present in the like after the last tube. Only nitrogen and argon will be able to come out from that last tube, and meaning that they are not reactive. So this experiment alone tells you that that air is actually a mixture. Now, nitrogen in air is relatively inert. It's not reactive. Because of that, it acts as a diluent. Diluent means it helps to dilute other gases. It serves as solvent for other gases present in air. And because it is not reactive, it helps us to slow down the process of combustion. For things to burn, it requires oxygen. Now, if oxygen is the only gas present in air, it will be impossible for us to light matches. Because if you light matches and there's oxygen in air, you just light it, just escalate the combustion and there will be explosion. In fact, it will be difficult for smokers to smoke cigarettes if there's no nitrogen in the air, because you just smoke the cigarettes and all your mouth will turn to burnt offering, and you don't want that to happen, right? So that is the importance of nitrogen in the air. It acts as a diluent, dilutes the other components of air, dilutes their function, dilute their capacity, in the air. And that is why it helps us to slow down combustion and also corrosion. Oxygen and water, they are needed for corrosion. if there's no nitrogen in air, just see that before 2 years, all the iron buildings in your house, all the iron structure in your house will have become corroded and degraded. So it is so nitrogen is helping us to slow down some of these reactions in the air. Is acting as a diluent. However, at a very high temperature, like the one we normally see during lightning, the nitrogen of the air can combine with oxygen in the air to give us oxides of nitrogen. That's what happens during lightning. The nitrogen from the atmosphere can combine with oxygen from the atmosphere to give us nitrogen oxide. And this compound, we're talking about them later, they are actually air pollutants. However, if this condition of high temperature is not present, nitrogen is inert, is unreactive except at very high temperature. Now let's look at oxygen. Oxygen is the second most abundant element in the air and is the most reactive element present in the air. Oxygen is necessary for respiration, is required for certain chemical processes to occur like combustion and rusting. Without oxygen, you cannot cook food. You cannot cook food using fossil fuel. You only be using all this electric method. But gas cooker will not work without oxygen. Your firewood will not work without oxygen. So oxygen is very, very important for combustion. Human being use it for respiration, and also rusting occurs in the presence of oxygen. So God bless you. We'll meet in the next video. Thank you.